Alright, let's get started with Lesson 6, Real Gases. Now, in this lecture video, we are going to compare the ideal gas to what we call real gases. Now, the ideal gases do exist, and so do real gases, but it depends on the conditions in which the gases are at will determine if the gas is an ideal gas or if it is a real gas. So we're going to kind of look at those conditions in a minute. But before we do that, let's look at the differences between a real and an ideal gas. So first of all, an ideal gas is mainly a gas that's mostly empty space. Okay, and a real gas is the same, under the same ideas. An ideal gas, the particles are in constant random motion, often straight line motion. Real gases, the same thing. So far, we haven't really seen any difference between an ideal and a real gas. But here we go. Here's some changes. In an ideal gas, there are no attractive or repulsive forces between the particles. We've talked about that. That is a governing idea of ideal gases. There is no intermolecular or electrostatic forces between gas molecules for an ideal gas. However, a real gas actually has very small attractive and repulsive forces between the particles. So there are attractive forces for real gases. There are intermolecular interactions with a real gas that occurs. Also, particles that are ideal, they don't really have a volume, meaning that they're spread out in a huge volume, a huge space. They're free. And I guess that's what we really should say, is that an ideal gas, the particles are free to move, to go. There's nothing holding them back to create a volume. Whereas in a real gas, because there are intermolecular attractions, the real gases, the particles do have a small volume. They're not quite as free to move around. They don't have that high, complete, full freedom of motion or movement. Also, for an ideal gas, when the particles collide, there's going to be no loss in overall kinetic energy. So remember that when molecules collide, gas molecules collide, according to the kinetic molecular theory, energy can be transferred from one particle to another, and that's true. However, overall, there's no loss in overall average kinetic energy. However, with a real gas, the collisions are inelastic. They're not elastic. And so that means that when collisions occur, that the system can actually lose energy or kinetic energy overall. All right, for a real gas. And so there's some differences between an ideal gas and a real gas that you should be very familiar with when taking this quiz and also taking the AP and IB exam. All right, so what are some of the conditions that occur for these molecules at ideal conditions or at a real gas condition? So for ideal conditions to occur, actually let's highlight that. For ideal gas conditions to occur, we mainly have an ideal gas that occurs at high temperatures and low pressures. And so when the pressures are low or you have extremely high temperatures, the gas behaves very much like an ideal gas, where you have complete freedom of motion and zero intermolecular forces that occur between the particles. Whereas with real gases, when the temperatures are fairly low and you have fairly high pressures, then intermolecular forces are going to exist. And when those intermolecular forces exist, then the particles do not have as much space between them, and they just don't have a complete degree of movement or freedom as you see with ideal gases. So these are the conditions I want you to just know. For an ideal gas to exist, we need to have high temperatures and low pressures, and for a real gas to exist, they need to be at low temperatures and high pressures. Now think about this for a minute. When you have high temperatures, you have gases that are moving at extremely high, fast speeds. And so because of those high speeds, there's not going to be much attractive forces that are going to occur. Whereas lower temperatures, the molecules don't move as fast, so the intermolecular forces are going to actually be there. And they're going to be somewhat strong enough to hold gas molecules somewhat in a space so that they can't move as freely about. All right? You can think of the same idea. High pressures, gases are compressed more at high pressures, and when gases are compressed more, they're closer together, and so there's going to be intermolecular forces between those molecules that occur with those compressed gases at closer spaces. What I'm saying is that when you increase the pressure, you compress the gas, right? And so the gas molecules are closer together, and so they have more of an ability to attract one another because of their close proximity to each other. Whereas if you lower the pressure down, the pressure being a lower pressure, the molecules are more spaced out. They're not as close together, and so the intermolecular forces can't grab hold of these particles and cause them to be attracted to each other at these lower pressures. All right? So I hope you kind of understand this idea. Review your notes, prepare for the quiz over this, review this lecture video if you need to for the quiz and the test, but that's essentially all that we have for now. All right?